Hello and welcome to Skyworks Power Supply Design video series. My name is Tamás Páni, I am an application engineer at Skyworks, and in this video I will offer an insight into RC snubber design. In the first section I will talk about the theory behind snubbers, why are they needed, what they do and the different implementations. Then we'll continue with the RC snubber design process, how can you tell which parts to select in the design phase, although most of the parameters will be finalized after a tuning process, which I will also discuss in detail. From the final section, you can learn which part of the design has an impact on the snubber and how can you make sure that it will work as expected, even if you need to change the original design. In part 1, I will focus on the theory of RC snubbers. If you are interested in the design process and change management, check out the second part of snubber design for SI340X. Now let's begin with the theory of operation. A semiconductor has several parasitic storage elements due to its structure. You can see the most significant parasitics on the simplified model. Since the values are small, this does not cause any issue in steady state. It is not the case though if you look at the transient behavior. The parasitic elements are causing a ringing, which is undesirable for several reasons. This ringing has energy which will leave the system in the form of dissipation. The amount of this energy is proportional to the switching frequency by nature. The amplitude of the ringing is related to the current flowing on the switch. This means that at high loads the power loss will be significant. Also, the voltage rating of the FET must be high to prevent part failure during ringing. FETs with high voltage rating usually have higher on resistance too, which leads to even more power loss. Fortunately, we can get rid of the ringing. This is where snubber circuits come into play. The simplest way of reducing the ringing is to place a capacitor between the drain and source. This is called a C-snubber. The idea behind the C-snubber is to place a capacitance in parallel with the switch big enough to make the inductive behavior of the switch insignificant. To have an effective C-snubber, one must pay attention to stray inductances, like the series inductance of the capacitor or the traces. C-snubbers can reduce the peak voltage, the frequency and time of ringing. If you add the resistor in series with the C-snubber, you get an RC snubber. The resistor dissipates the energy of the remaining ringing, reducing ringing time drastically. This snubber topology is widely used for switch mode power supplies because the efficient damping, low-cost parts, and easy implementation compared to the more complicated topologies with diodes. Thank you for watching. I hope you learned something new about the theory of RC snubbers. Check out snubber design for SI340X Part 2, where I will guide you through the design process step by step. For further information, visit skyworksinc.com.